Welcome back to today's session. Yesterday we discussed the Hungarian algorithm. So we are supposed to look into how this algorithm can be applied to solve a problem. So before I start off with the problem, a brief recap or a fast recap of the algorithm. Step 1, if at all the problem is in maximization case, we have to convert it to minimization. If it is minimization, retain it as it is. Step 2 is if it is not balanced, balance it by adding dummy row or dummy column as needed. Step 3, row reduction, choosing the minimum element of each row and subtracting it from the other elements of the same row. Then step 4, column reduction, choosing the minimum element of every column and subtracting the same from the uh, respective columns. Then assignment step, where we will look into the available zeros and make allocation. And whenever we make an allocation, if at all there is any additional zero in the same row or same column, I'll have to cancel it or cross it on. Then step 6 is if at all we have not yet arrived at the final solution expected, then we are supposed to draw horizontal lines and vertical lines so that all the zeros are covered. The number of lines normally will be equal to the number of allocation made. How to draw lines? So first, pick the row with no assignments, and in that ticked row, columns which have marked zeros have to be ticked. From that ticked column, tick the rows which contain assignments. Now draw the lines from the ticked column and unticked rows. Choose the minimum number from the uncovered elements. That is, we are supposed to choose the minimum uncovered element, subtract that from all the uncovered elements, and add it to the point of intersection. So this process will be repeated until we find the solution for the problem, right? Now we will have a look at the problem and see how this algorithm is implemented. So we consider a problem here. Solve the following assignment problem whose cost matrix in rupees is as given below. So I have 4 workers A, B, C, D, and I have 4 jobs 1, 2, 3, 4. So we are supposed to make an optimal assignment so as to minimize the cost. How do I get to know whether it is minimization case or maximization case? Because they have specified it as cost matrix. Anybody would be interested to reduce the cost. If at all it was profit, then we would be interested in maximizing the profit, right? So because cost has been specified as a decision variable, it is minimization case. And how many rows we have? 4 rows. How many columns we have? 4 columns. So it is a 4 cross 4 matrix. That means to say it is a square matrix. So the given problem is minimization case and it is also balanced. So no need for step 1 and step 2. Straight away we go into the next step, which is row reduction. So how does row reduction happen? We will have a look. Look at the first row, which is the minimum most element. We have 42, 35, 28, 21. 21 is minimum. 30, 25, 20, 15. 15 is minimum. 30, 25, 20, 15. 15 is minimum. 24, 20, 16, 12. 12 is minimum. So we have noted all the minimum values. Now we are supposed to subtract 21 from 42, 21 from 35, 21 from 28, 21 from 21. So we will see the result. 42 minus 21 is 21. 35 minus 21 is 14. 28 minus 21 is 7. 21 minus 21 is 0. Similarly, coming to the second row, 30 minus 15, 15. 25 minus 15, 10. 20 minus 15, 5. 15 minus 15, 0. Because these two rows are the same values we'll get. 15, 10, 5 and 0. Coming to the last row, 24 minus 12, 12, 20 minus 12, 8, 16 minus 12, 4, 12 minus 12, 0. So we have got the result of row reduction. For this cost matrix, we need to apply column reduction. Why are we applying column reduction? Because all columns do not have zeros. See, after row reduction, I got at least one zero in each row, right? I have got zeros in all the rows, but in all the columns, I don't have zeros. So I'll have to perform column reduction. So perform column reduction. Minimum of the first column is 12. Minimum of the second column is 8. Minimum of the third column is 4. Minimum of the fourth column is 0. So subtracted 21 minus 12, I get a 9. 15 minus 12, I get a 3. 15 minus 12, 3. 12 minus 12, 0. 14 minus 8, 6. 10 minus 8, 2. 10 minus 8, 2. 8 minus 8, 0. 7 minus 4, 3. 5 minus 4, 1. 5 minus 4, 1. 4 minus 4, 0. Because I have a 0 here, all the values will remain 0 itself. Now you observe one thing, that every row has a 0. A has a 0, B has a 0, C has a 0, D has a 0. Similarly, all columns contain zeros. See, 1 has 0, 2 has 0, 3 has 0 and 4 has 0. Now when all rows and all columns contain at least one 0, we are ready for assignment step. So now we perform assignment step. So we'll see how to perform assignment. So in this, uh, either you can go row wise or column wise. I would always prefer column wise. So what I did is, looked into the first column, I had only one 0. So I made an assignment there. I put a dabba there. Fine. In the same row, I had three more zeros. I crossed it. Fine. I made an assignment here. After making an assignment, any zeros in the same row or same column has to be crossed off. So this column now does not contain a 0. This column does not contain a 0. This column contains three zeros. So I make an allocation here, and in the same column I had two more zeros. I will cross it off. Fine. So now the assignments are made. How many assignments did I get? I got only two assignments. How many I am supposed to get? Because I have four jobs and four workers, I should get four assignments. But I've got only two. So that means to say we have not yet achieved the final solution. So what next? If we have not achieved the final solution, go with drawing the lines. So how to draw the lines? First, right? Tick the row which does not have an assignment. B does not have an assignment, tick it. C does not have an assignment, tick it. So these two rows got ticked. In the ticked row, wherever there is a crossed zero, tick that column. So in this row, I have a crossed zero here, so I tick this column. In this row, in the same column I have, so whether I tick it once or more than once, it is the same. So I got a tick in this particular column. Now in the ticked column, wherever I have an assignment, tick that row. So I got an assignment here, so I tick the row. Fine. So now in the ticked row, do I have any crossed zeros? No. If at all I had a crossed zero, then corresponding column had to be ticked. Now I don't have any crossed zero here, so the ticking stops. After ticking stops, what are we supposed to do? draw lines. How do you draw lines? Ticked column has to be drawn a line. So I draw a vertical line here, and unticked rows, which is unticked row, D. So I draw a line, one vertical line on 4 and one horizontal line on D. One thing that you observe is all the zeros that I had in the problem are covered under the line. Fine. All zeros are covered under the lines. Once this is done, what is the next step? Out of the remaining uncovered elements, find out the minimum value. Which is the minimum value out of this uncovered elements? 1. So I write the minimum value is equal to 1. So what am I supposed to do now? Subtract this minimum value from all uncovered elements. So this 9 minus 1 will become 8, 6 minus 1 will become 5, 3 minus 1 will become 2. Here it is covered, should not touch it. 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0. This is covered, don't touch. 3 minus 1, 2, 2 minus 1, 1, 1 minus 1, 0. This is covered, don't touch. 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 This is point of intersection. Here you are supposed to add the minimum value. So this 0 plus 1 makes it 1. So the resultant is 8, 5, 2, 0, 2, 1, 0, 0, 2, 1, 0, 0, 0, 0, 0, 1. So this is the new cost matrix that I've got after subtracting the minimum from all uncovered elements and adding at the points of intersection. Now check whether all rows have zeros. Yes, all rows have zeros. Check whether all columns have zeros. Yes, because all rows and all columns have zeros, I don't need a row reduction or a column reduction. Straight away I can go to assignment step. So now we again go to assignment step. In the assignment step, I go column wise. So I look into the first column, I got a 0, I make an assignment. In the same row, wherever I had a 0, I cross it. I cross this 0 and I cross this 0. Now the second column does not have a 0. Go to the third column, I have a 0 here, make an assignment. In the same row, I had a 0, cross it. In the same column, I had one more 0, cross it. Fine. So now go to the fourth column. I have only one 0 which is open. So make an allocation here or make an assignment here and cross this 0. So how many allocations I've got or how many assignments I've got? 3. How many I'm supposed to get? 4. So have I arrived at the final solution? No. Still we have not arrived at the final solution. So what next? We need to go with drawing the lines. How to draw lines? Tick the row with no assignment. Row C does not have an assignment, so I tick it. In the ticked row, wherever I have a crossed 0, tick the corresponding column. So I tick this column and I tick this column. In the ticked column, wherever I have an assignment, tick that row. In this column, I have an assignment here, tick this row. In this column, I have a assignment in this row, tick it. Fine. So in the ticked rows, I don't have any other crossed zeros. So ticking stops. Now draw the lines. How to draw lines? Ticked column, vertical lines, unticked row, horizontal line. So how many lines I've got? 3 lines. How many assignments I had? 3. So if at all your number of lines that you have got is equal to the number of assignments, then we can go with a belief that your line drawing is correct. Now I have drawn the lines. After drawing the lines, what am I supposed to do? Check whether all the zeros are under the line. All zeros are under the line. Yes, all zeros are covered. Now what next? Out of the uncovered elements, find out the minimum value. Which is the minimum out of the uncovered elements? Obviously 1. So minimum is equal to 1. What next? Subtract that minimum from uncovered elements and add it at point of intersection. So we'll see that. 8 minus 1, 7. 5 minus 1, 4. 2 is covered, don't touch. 0, covered, don't touch. 2 minus 1, 1. 1 minus 1, 0. 0 covered, don't touch. 0 covered, don't touch. 2 minus 1, 1. 1 minus 1, 0. 0 is covered, don't touch. 0 is covered, don't touch. This 0 is also covered, don't touch. This 0 is also covered, don't touch. This is a point of intersection. What am I supposed to do whenever I encounter a point of intersection? Add the minimum value. So 0 plus 1, this becomes 1. This is also a point of intersection. So 1 plus 1 becomes 2, right? So the result of subtracting the minimum value and adding at the point of intersections, I get 7, 4, 2, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 2. So this is the resultant cost matrix after subtracting the minimum from all uncovered elements and adding at the points of intersection. Now check whether all rows have zeros. A has a 0, B has 0, C has 0, D has 0. Check whether all columns have zeros. 1 has 0, 2 has 0, 3 has 0, 4 has 0. So no need of row reduction or no need of column reduction. Straight away you can go to assignment step. Now we'll go to the assignment step. So in the first column, I had only 1 0, make an allocation. In the same row, I had one more 0, cross it off. Now in the second column, how many zeros I have? 2 zeros. So the first 0 that I encounter, I make an allocation. In the same column, I had one more 0, cross it off. In the same row, I had 2 more zeros, cross it off. Now how many zeros I have in the third column? Only 1 0. So make an allocation. Cross off the 0 in the same row. Now in the fourth column, how many zeros I am left out with? Only 1 0. Make an allocation. So how many allocations I got? 1, 2, 3 and 4. How many I am supposed to get? 4. So I was supposed to get 4 assignments. I have got 4 assignments. So this is the final solution. So can we leave it at that? No. We are supposed to find the total assignment cost. So we are supposed to write the final solution is A is assigned to 4. A is assigned to 4. B is assigned to 2. B is assigned to 2. C is assigned to 3. See, C is assigned to 3. D is assigned to 1. So D is assigned to 1. So corresponding costs I am supposed to write. So where do I get this cost from? This cost should be taken from the original problem. In the problem, A to 4 was 21. See, A to 4, I have put 21. B to 2 was 25. C to 3 was 20. D to 1 was 24. Right? From the original cost matrix given in the problem, from there I take the values and I put it here. After putting it, I am supposed to add all these values. 1 plus 5, 6, 6 plus 4, 10, 0, 1 carry, 2 plus 1, 3, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9. So I get a 90. So the total assignment cost denoted by TAC is equal to 90 rupees, with the assignments being A to 4, B to 2, C to 3 and D to 1. This is the final answer. Hope you people have understood. This is one of the most simplest problems that you can think of. Third standard problem, right? So nothing but addition, subtraction. That's all. That is what you are doing. Little bit of brain and your third standard mathematics. You will be able to solve this problem. A very scoring problem for you. Fine. Hope you people have understood this problem. Now, one small problem for assignment. So now have a look at this problem. This is also a AP which has been given with a cost matrix. So it is also a minimization case. How many rows I have? 5 rows. How many columns I have? 5 columns. So it is a balanced problem. So like the problem that I have solved just now, you are supposed to solve it. This will be your assignment. So where are you supposed to submit it? In the comment section. You will have to submit the TAC, total assignment cost, and the assignments that you have got. Right? Done? Okay. Thank you for your patient listening. Write your assignments, submit it by tomorrow. Day after, you will find the solution for the problem in the classroom platform. Till then, thank you. Have a nice time. Enjoy.